In this video, I'd like to cover the C++ branching syntax in a little bit more detail and then give some examples to demonstrate that syntax. When creating branching structures in C++, we'll need three reserve words: if, else if, which is actually two words, and else. Of these reserve words, the if is actually the only required part of a branching statement. The else if and else commands are technically optional and should be used to fit your specific situation. It should also be mentioned that else if is repeatable, allowing us to have as many branches as we need. What comes to the right of either the if or the else if reserve words is the condition that we'll be checking for, and the condition we're checking for must be written within parentheses. The else reserve word is actually a catch-all, and so there should never be any statement following the word else. It will appear by itself on a single line. Although a semicolon is like a period in the C++ language, and it's generally best practice to think of that semicolon as ending every statement, the if, else if, or else statements and anything on a line with them does not actually end with a semicolon. Instead, following the words if, else if, or else, and any statements that are associated with those words, we'll be using braces to define the block of code that belongs to that branch. The code that we write within the block will only be executed if the condition associated with the if, else if, or else statement is satisfied. To repeat, all the code that you wish to be executed for that specific case must belong to the block of code associated with that branch. Now, the previous slide was a lot of rules, and we're going to next do a lot of examples to hopefully demonstrate those rules. The very first thing we mentioned is that the else if and else commands are actually optional. What that means is it's occasionally the case that there's only an action we wish to perform in one condition, and we don't really need to do anything otherwise. This typically manifests when there's action required, but only in one case. Thus, all we need to do is check to see if that case is satisfied, in which case we want to execute the block of code, but we wish to do nothing otherwise. An example of this is written below. What we have here is a small program asking a user to give us a numerator and a denominator, and the purpose of the program is to print out the numerator divided by the denominator. However, there's a rule in division that we're not allowed to divide by 0, and since the user is entering the numbers, it's possible that they could enter a value of 0 for the denominator. Therefore, in line 13, we create a single if statement, the purpose of which is to check whether the denominator is equal to 0 or not. In C++, an exclamation point followed by an equal sign means not equal to. So the line of code in line 13 reads, if the denominator is not equal to 0. In the case that the denominator is not equal to 0, which we hope is all cases, we wish to go ahead and perform the division numerator divided by denominator. However, if the denominator were equal to 0, we would not be able to perform this division without crashing our code. Therefore, it's very important to check to make sure that this important condition is satisfied, and only perform the division in that case. For a second example, let's look at another small program. The purpose of this program is to compute how much money a worker should receive based on their hourly rate of pay and the number of hours they've worked in the week. However, we're going to be following a standard overtime rule of some companies, which is that any hours worked greater than 40 receive time and a half pay. In this code, an hourly rate for a worker is identified in line 7, where the number of hours worked is a variable declared in line 8 to be input by the user in line 11. In line 13, we declare a variable called pay that has not had a value set for it yet, because the value we attribute to pay depends on the number of hours worked. In line 14, we check to see if the number of hours worked is less than or equal to 40. In that situation, there is no overtime to compute, and the pay is simply the hourly rate multiplied by the number of hours worked. In line 18, we see the word else, with no condition following it. The flow of control will reach the block of code that's associated with the else statement in the event that the code in line 14 is false. That is, if the number of hours worked is greater than 40. In that situation, our first 40 hours will be paid at the hourly rate. However, the number of hours above 40 will be paid at 1.5 times the hourly rate. The way we represent the number of hours worked over 40 is to take this variable, hours worked, and subtract 40 from it, noting that this will be a positive number whenever the flow of control reaches line 20 in the program, because the only way to reach line 20 in the program is for line 18 to evaluate to true, which is to say line 14 evaluates to false. That is, the number of hours worked is greater than 40.